I'll try to code the third challenge, the challenge of day 3. As always, I'll try to explain the flow of TDD while I live code the solution, starting from a test and ending with the code that needs to be tested and inputting the solution that we have. I heard rumors that the solution of today is way more difficult than the one from yesterday. We'll see about that. So let's get started. I'll start from a test, like I said. I'll create a new class. I'll call it crossed wires test. And give me a moment to see if it was announced. It wasn't announced, but I think it will. Can I give a link fast? Twitch.
And they're going to be looking to buy.
Whoops. Whoops. Okay. I'll give a link fast and we'll carry on. All right, let's continue. So like I said, we start from a class, a test class. And for now, I don't really know what I'm going to test, so the name will probably change as well. There's always input, so I'll add the folder for it. And some sort of a file, which seems to be map.txt. And of course, I don't want anything. And that's all I know for now. So now let's start reading the task and getting the spec out of it. The gravity, so day 3, crossed wires. The gravity assist was successful and you are well on your way to the Venus. Refueling station. During the rush back on Earth, the fuel management system wasn't completely installed, so that's next on the priority list. Give me one moment. All right, let's continue. So there is a station. So I'm at the station. During the rush back on Earth, the fuel management system wasn't completely installed. So that's the next on the priority list. Opening the front panel reveals a jumble of wires. Specifically, 2 wires are connected to a central port and extended outward on a grid. You trace the path each wire takes as it leaves the central port. 1 wire per line of text. Opening the front panel reveals a jumble of wires. Specifically, 2 wires are connected to a central port and extended outward on a grid. Okay. You trace the path each wire takes as it leaves the central port. Okay. 1 wire per line of text. Okay, makes sense. The wires twist and turn, but the 2 wires occasionally cross paths. To fix the circuit, you need to find the intersection point closest to the central port. Okay, so we got our first thing to find. Should returns returns closest intersection point. Something does this. For now, I don't know what will happen exactly. We'll see. Because the wires are on a grid, use the Manhattan distance for the measurement. Manhattan distance is basically you don't go sideways. You always go either up, down, left, or right to calculate distance. So in this case, it would be 1, 2, 3 distance to this, and till this one, it would be 4, 5, 6, and 7. So total distance from this point to this point would be 7. Let's continue. While the wires do technically cross, right at the central port where they both start, this point does not count. Nor does a wire count as crossing with itself. For example, if the first wire path if the first wire's path is R8, U5, L5, D3, then starting from the central port 0 or 9 capital O, it goes right 8, up 5, left 5, and finally down 3. R8, okay. Okay, but what's up with R, U, L, D? Oh, okay, that's the input we'll have. Okay, good. So that makes sense. Then if second wire's path is U7, R6, D4, L4, it goes up 7, right 6, down 4, and left 4. Yes. Is U7 1, 2, 3, 4, 5, 6 doesn't make sense. 1, 2, 3, 4, 5, 6. I guess 7. Okay. Right 6. 1, 2, 3, 4, 5, 6. Okay. Down 4, and then left 4, and cross intersections. All right. These wires cross at 2 locations marked X, but the lower left one is close to the central port. What is the central port? Is it the center? Find the intersection point closest to the central port. Opening the front panel reveals a jumble of wires. Specifically, 2 wires are connected to the central port. Oh, that's the central port. Oh. And X is intersection, and this intersection is the closest to this point. Okay. These wires cross at 2 locations. Yes. Here are a few examples. What is Manhattan distance from central port to the closest intersection? Okay. Fair enough. Sounds reasonable. I thought it would be harder, but I'll bite my tongue and solve it. So let's first make some spec and add the conditions, the test input. So this is, what's the input? What's this? So 2 wires, I guess. Okay. And this is also 2 wires, right? So I need to make the most simple input possible, and also it's a theory, and I'll take data from a class because there will be quite some data and I don't want to pollute test with input stuff, just data. So let's create a class which will hold those 2 test cases, input for test cases. So wires, valid wires. And we need to implement IEnumerable of object array, so that we provide the input for our XUnit test theory. So yield return and inside we'll have 2 more arrays. So it's an array of strings actually. That's how wires are defined. And another one will be also an array of strings, and we don't know the size. And for the first input, I will try to be very specific. So crossing wires, that's the input that we are having. And pairs of crossing wires is what it provides. Now, what's the most simple crossing wire? I think I'll grab a map and sketch it out. So we start at 0 somewhere here. And this is our wire, this is our wire, this is our wire, this is our wire. And they need to cross somewhere. I don't need to go that much. Yeah, I think a little square is the place where it kind of crosses the soonest. So like this. One and then intersection. So what do we have? We have 1, 2. And I probably have, you know, a map. It can go on like this. Okay. So we start at 0 and our first wire will go 2 to the right, 2 up, 1, 2, 3 1, 2, 3 right, sorry, 3 left, so we can write it down. It will go 1, 2 right, 1, 2 up, then it will go 2 left, 3 left, and that's it. And the other one will go 2 up, and that's it. Or 3 up, 2 up is better. 3 up is more clear that I'm, well, 2 up is actually a boundary condition, so it's more meaningful. Okay, we have our wires, and they're not with spaces in between. So let's clean our input and let's take it. So that's the first one. Thinking if it's better, yeah, I think it's better to just have it as an array of strings, because parsing it is a different thing, and I shouldn't waste my time parsing it if I don't need to. So, right, and the other one was 2 up. And that's it. And they both start somewhere at some point. It doesn't matter actually where, because the map, if I imagine, is the bounds are infinite. It can go infinitely to the right, infinitely to the left. Okay. And I presume those will be always capital letters. And I see that they start with 1. U2, L3, U2. Okay. Now let's make our code to accept that input. So we take in do we take array? Do we take a list? Do we take an enumerable? I think we take array of strings. So wire 1, and we take wire 2. And class data, type of. So we say, where do we get our input from? And we get it from not valid wire, but from crossing wires. Input. Good. And what do I do? We do something with the wire, and we also need to get the expected answer. What happens after we find the cross section and measure the Manhattan distance? So I need a distance as well. So what's the distance between these two? And the answer is 2. Between the cross section, which is here, and this point. And the answer is 1, 2. So that's the most simple case I can think of. object because it doesn't know, it cannot guess what type it is inside, what each element is, so I need to specify explicitly that it can be anything. Okay, back to our test. Expected distance. Also a thing to note, those numbers are not negatives, I think, ever. Yeah, I think they're never negative. Though it does make no, it doesn't make sense to go negative 34 if you can just go d34. So probably no negative, so I'll just use uins. Anyways, so is there anything that mentions the component that could unwire those things? How should we call it? We will have a calculator for Manhattan distance, that's for sure, which will calculate the distance, but now we need to map the wires and get the cross sections, these points. Sorry, these points, the x's. So we need to come up with a name for a component which will do that for us. Let's think. And also let's go back to this and see if we understand correctly. 1, 2, 3. 1, 2, 3. Yeah. So it can go 1. Actually, it's ambiguous. Actually, no, it's not. It doesn't have to go the path that it already has. It can just skip everything and go straight to it through it cannot cut corners. It goes through corners. It's Manhattan distance, but it doesn't need to follow a wire that's already laid. So I think the first part is to get those points. And with those points found, the cross-section points, we can then count the distance between those points, and it's fairly simple. The distance will be literally just the coordinates summed. The difference of coordinates between this point and this point is the distance. So distance is trivial. Cross sections is quite hard. But I think we do need to have cross sections separately. It makes sense to have a method for it. So I'll call the component wire untangler. And I will say that it takes 2 wires and what does it do from it? It it shouldn't take the wires per se immediately. It takes a panel, and a panel contains 2 wires. I imagine a panel can contain more than 2 wires, so there will be more intersections. So it accepts a panel. So we have wire untangler, that's it. And wire untangler, for now, untangles 2. So we say mark cross sections. Get cross sections. So we get wire 1 and wire 2. So we get our cross sections. And that's it. That's our first method that we're gonna check. So that one will go later. I'll comment this one out. It's the next step, and the first step is a bit different. So I'll take one more input class, and I'll call it crossing wires input. Distance is this much. Smallest. Right, so the other one is a bit different, as I need to find a single intersection or 1 or 2 intersections. So I need a few cases. So the most trivial case for tangled wires input. And what's this one? Crossing, tangled wires input. Very ambiguous. I need to think about it. Crossing wires input smallest. I'll call it tangled. Tangled is a better name. Tangled. Good. Tangled wires input. All right. The same stuff. Enumerable of object array so that we can use it as class data. We implement missing members. We say that we get a numerator, and that's it. Very similar. I'll copy this, but the input will be different. So this is a map for tangled wires distance 3. Sorry, distance 1, 2, 3. Sorry, we start at here, so we are already here. So 1 and 2, so distance is 2. That's the input. Without, of course, the without that. Perfect. And the other one will be Save, of course. The other one will be, I'll steal that as well. Smallest cross section. Actually, that works as well, right? You go here and then you immediately, well, you can't go like this. I don't know why I wrote it like that. So 2 to the right, 1 up. What if I go 1 right, 1 up, 1 right, 1 up. Yeah, that works. 1 right, 1 up, 1 left. 1 right, 1 up, 1 left. And that's it. And the other one, 1 up. That's the smallest one, actually. And the distance is 1. Yes, and the same can be applicable to both, so I don't need those two. Distance 1. I don't need those two. Tangled wire input smallest. Good. Tangled wires input. Perfect. Now I just need to figure out how do I eliminate this bit. In one case, we need tangles themselves. So basically a third list of strings which indicate the coordinates. So maybe not the coordinates, but yeah, a vector probably with x and y. A list of vectors is what we need in here. So the problems that we need to solve in this one come down to 3 problems. Number 1, find cross sections. Number 2, measure distance. And then number 3, find shortest distance. So there are 3 sub-problems that we need to solve, and solving those will give us the answer. All right. Let's continue. So this one, tangled wires input. Tangled wires input. I really hate duplicating it. Oh my gosh. Is input smallest distance for distance, and the other one will be for, even though I hate it, I don't know how to make it better, I'll refactor later. Something, I'll paste and rename. Tangled wired input, not for distance, but for tangles. Yes, please. Thank you. Good. And again, distance we don't need yet. Tangles, yes, please. So the output will be tangles. And for tangles, we need some sort of struct to represent a coordinate. So let's create a struct. Point, I think. So it has public, read-only, uint, x, public, read-only, uint, y. Point into the space. And we need, of course, a CTOR. All right. No comments for x and y because it's obvious what it is. Next. So what do we expect? If I look back at the map that we drew, we expect if hello Draco, if we take a pivot point 0, then our first tangle point, oh crap, this is still old. Our first tangle point will be, thank you for following, Draco, will be, we first go right, up, and then left. So the intersection is here. We go right, up, left, right, up, left. And if the other one goes up, we have intersection. And we have intersection at relative coordinates 0, 1. If it's 0, 1, then I say it's new point. Oh. Well, our point. Point. Leave me alone, I don't want drawing. I want this point with 0 and 1. What are we saying? We're saying that given one wire is forming a corner and the other one going straight, 1 unit up, the cross section will be at this point. So we have this, and we need the untangler. And we need to move it to the class, to the proper place. So let's first say resharper move to the class, and move this class to the proper place. So much easier to refactor with resharper on. And resharper, please add the method. And this method will now return the most simplest point ever. It returns an object, and in actuality, for how long have you been programming? I've been programming for 3.5 years. I mean professionally, as a career. and in general for 4 years more, but not that actively. So we return, I'll return iList, I like lists, of point. So wires expressed in, I went to university. Wires expressed in literals, cref. We'll express that. So we need our literals. Basically points that we can move to. I went to Kaunas University of Technology and graduated 2 years ago. Or yeah, roughly 2 years ago. So, Lithuania, by the way. Direction, literal. Roles. Yeah, plural. Actually, not sure if plural, singular. Doesn't matter. Recently, I got to liking constants rather than enums because I don't have to do the casting, so it's beneficial. And at the same time, I don't have to, I can use a string as well if I need to. I don't need to convert that to string, if the enum to string, so much benefit. Actually, it's chars. So chars. L. So left is L. Right is R. Up is U. And down is D. Go left, followed by X units. Go right, followed by X units. Go up, followed by this many units. And go down, followed by this many units. Direction, literals, indicating the path the wire moves. Not necessarily the wire, indicating a direction. So we have the class, and now we can make this a bit more clear and specify it. So we say wires expressed in literal and literals. And yeah, here is where they are expressed. Followed, yeah, that's it. Wires expressed in literals, followed by an integer for how many units to move in that direction. And yeah, no need units. Good. And now we need to make this minimal and at the same time so it fails. So we're writing a failing test, in other words, a test for our test. So to know that our test at least compiles. A list of points, that's what we return. An empty list of points. And that's it. And what we expect to get is at least 1 point. And actually an array. A list array. I will be working with a list because I will be stacking those. But in the end, I should return something general. Well, I should return IEnumerable so that I can treat it in more generic way. So we return this. And if I go here, tangled wires input for tangles reads better. All right. For tangles, what we expect is of points. And we get points and we compare them. So we say cross sections should be equivalent to expected cross, just call it tangles, I guess. Expected tangles. Tangles sounds so much better. Cross sections versus tangles. Get tangles. Find tangles. I think it's even better. So we find tangles and get them back. And we say that our tangles should be as expected. So tangles should be equivalent to expected tangles. And if I run this now, it should compile and say that my test failed. I'll move it here, somewhere there. It says my test failed. Can I put output in a more reasonable place? I guess not. So we have our requirements. I will get back to it again when we transfer the rest of the input, the real input, back. But now we're working with code. We more or less know what we need. With one item but found an empty collection. So our test itself is having a good structure. It's failing, so now we can move on adding minimal code to make the test pass. So we need to find tangles. So we go to this method and we need to implement it now. I would like to have this in front of me because it's pretty useful, I think. I'll close the window for tests as we really don't need it anymore. Let's implement it. Definitely not what we want. Kind of. We start from an empty list. And we say return tangles. And now let's work with it. So what is a tangle? A tangle means that a point for this wire overlaps with a point of that wire. So I could create all points that this wire has and all points that this wire has, and then use a link queue to join them, and the result will be the tangles. Now, is this efficient? That's a greedy algorithm because I don't really put much effort into coming up with it. What smart optimizations could we make? I don't really know. So I'll use this solution. So the first step is to parse a wire into points. So I think I will make a struct for a wire. And it basically has a list of points, enumerable. No, a list of a list of points. Or path is wire path. Yeah, so a wire has a path. And doesn't change. And this is I read-only list because I don't want people to change it. A wire will be immutable upon being created. So when I create a wire, I pass in a string array or a string array. So path also. So now we need to parse this path into points so that we can have something meaningful to work with. So we will also need to write a test for parsing it. So let's go back to test and write one more test for parsing that kind of wire into path. So I'll say wire tests. And we say wire no, single direction literal returns D7 L7 returns literal returns passed to wire, literal for wire initialization, returns minus 7 x minus 7. And I don't want to hard code this, so I need to replace those with something else. Valid literals in string array for wire initialization returns expected points. Good. So I will pass a list of strings basically this, except I now only need one. And I'll actually copy paste. So I call this tangled wires single wire direction, single wire literals. Expectations. Input. Yeah. Expectations is actually better. And I'll rename it to all of those. For all of those. Expectations. Tangled wires input. Expectations for tangles. Good. Now we can proceed. So we take only one. So the most simple one. If I go right once, the coordinates will be a single point with 1, 0. That's it. So if I go here and I say class data type of, so we take our input from tangled didn't rename it yet, wires expectations expectations distance and the same for this one and the same for this one. So going right once will result in such a literals, such a position, point array. So what do? We say wire is new wire with literals. Call it path, I guess, slightly better. And we say that wire path should be equivalent to points. So if I run this test now, what's wrong? Oh, I forgot theory. What's wrong? Public, I forgot void, okay. So if I run my test now, right, path is new for now. For now, will change. So we have a minimal test that fails, but compiles. So if I run this test, it says expected with 1, but empty collection. Perfect. Let's implement this. So we don't do this. We parse the path. Private, static, iList point, parse path. What do we say? We say that path is new list of point, and we say that I guess it's literals. Nah, it's path. So we take literals, whatever. We say path is new list, and we say that select literals, select we build a point. So I think this will be really trivial. But then I'll need a test for a point. So let's go back here to point, and let's add one more CTOR for it to accept a string. So if I create a point from a string, coordinates, can I really create something meaningful? I need a pivot point always. So I cannot. Okay. Let's scrap that idea. I need a pivot point. I need a pivot point when parsing this. So private, the first position per se will be the pivot point. And I need to keep track of direction it moved. And that direction will be X and Y that keeps on being stacked. So I don't think LinQ is good enough for me in this case. So I say that var X is 0, var Y is 0, and that for each of those literals, I do something like I parse the literal and I add it to the X and Y. And then I create a point out of it. So I parse the literal. So I need to split a digit part from letter part. Private static. I think it's perfect for tuple. And I'll get back to uints. And I'll call it parse literal, which is a string. So I say return, I say first letter is always direction. So I say literal 0. And then what follows is position. So I'll have a dictionary for char character, which indicates direction. Positive or negative, which indicates a multiplier actually. And for simplicity's sake, I'll use ints. It's int, it's not uint, because it can be negative. And it will be negative. So, dictionary. Private static dictionary, char to int, and direction. It will be... I'll create this dictionary when I refer to the wire for the first time. So static wire direction is this. We have direction literal, down translates to -1. Up translates to 1. Left, -1. Right, one. It's a bit redundant, so using static direction literals, and I don't need this anymore. Good. So we have this, and direction multiplier. And this will be actually a short, or something shorter. Does anyone know if there's anything shorter than short for both positive and negative range? So we have direction, and this direction determines if it's positive, negative, and if it should also determine if it's x and y. How do I determine that? How do I determine if it's x or y again on top of what I have? I think if I used C# of 8.0, I could use pattern matching, and that would be quite nice. Yeah, I don't need this dictionary actually. I know a better way. So it goes like this. So direction, and another one is units. And units is literal without without the character. I want to remove it. Oh, I'm stupid. Replace. Remove. Returns a new string in which all the characters in the current instance begin at a specified position. Also, awesome. This is perfect. Exactly what I need. So all except direction, and I say short. I don't want short. Int dot uint actually. Uint dot parse. int, because I don't want conversions. Int dot parse perfect. Okay, so I parse the point, and that would work. What do I do next? I want to check if it's valid or not. If direction any if direction is not a part of, okay, I will combine those literals into one. Public const valid string valid and LRUD, all valid literals, direction literals combined. So if wire, if valid does not contain direction, then I throw not supported literal exception. Unsupported. Direction literal exception. So we have a char, literal, and the message that we'll have is literal is not a part of supported literals, which is, whoops. Actually, I'll just put it in one single quotes, easier. Dot and literals dot valid. Good. And unsupported literal exception. Throw new unsupported literal exception for direction. Next, I got direction right, so now I take the units. And if I fail, units. I don't know what. And then I say int try parse out try parse this out units. And I say var is number. If is not number, throw new yeah. I guess it could be a part. String for first literal, and I'll just call it literal. Unsupported literal exception. First literal for all except first literal. So is not a number. Is not an integer. And we say we take this and say var unit literal, and we parse it, and then we say that it's not that. And then we say if direction is up, then it means x is 0. Yeah. So if it's up, then x is 0, y is minus 1 times units. Break. Case down. X is 0, y is minus 1 times units. What's wrong? I didn't break. Case left. X is minus 1, y is 0. Minus 1 times units. Break. Case right. X is 1 times units. Y is 0. Break. And I could have checked for one more, but in this case, I no longer need to. So it's fine. And finally, we return a tuple, which is x and y. Which is shorts. Ints, okay. What's wrong? Might not be initialized. Okay, good. So now we say, right, we need those x's. Origin point. And then we say literals. Wait a minute. No, yeah, fine. We say literals, literal. We say parse, literal. Var. Why can't we return a point? Why do we need to return a tuple? Good question. It's actually a point. So here we say point is parse literal. So we have our point. Direction point. Actual point is x and y plus. So x plus equal direction point x, y plus equal direction point y. And it long, sure. I won't cover edge cases, too lazy right now. And actual point is directional is new point, var actual point. Point that takes in x and y, always relative. And it's long. Should be ints. Okay, I'll explicitly cast. and it's not, it can be int. It should be int because it can go down. So it would be messed up if I don't do this. Okay, and then we add those to our actual path. So path.add actual point, and in the end we return a path. So with this we have a wire with its own path. If I go back to wire tests, it should now work. Empty collection. It's empty collection because I didn't do anything yet with the way I parse it. I didn't use it. So path parse from path. From this path. I need to cast. Or I can return. Probably cleaner. Yeah, awesome. Is not an integer. Huh. So what do we have in our input? We have R1. Oh, wait. When we parse it, we returns a new string in which all the characters in the current instance beginning at specified position. So the start index is 1. It's not an integer. Okay, so why is it R? R1 is R. Okay, so again, let's read it. Returns a new string in which all the characters in the current instance beginning at the specified position and continuing through the last position have been deleted. Okay, substring is what I needed. It works. So now we can go for more complex cases. So let's add one more case. If I have R, yeah, sure. If I have R2, it will be new point 2, 0. Quite trivial. And then let's continue. If I go up, so I should first add trivial cases, such as I go 1 unit up. If I go 1 unit up, it should be 0, 1. If I go 1 unit down, it should be -1. If I go 1 unit left, it should be 1 -1, 0. And if I go there is good. I'll move this in the end. If I go 1 unit up and then 1 unit left and then 1 unit down, it should be 1, 0, up 1, 1, left 0, 1, and then 0, 0. So like a square. Let's test. Perfect. Our wire parse works. Let's go back. So instead of, we pass in path, path 1, path 2, and it finds tangles in wires. So I take in 2 wires. Which has path 1 and then another one, path 2. So I find tangles and I return them. Now finding tangles when I have the wires should be quite easy, because I could just say which points are matching. So I say wire 1 dot path dot join wire 2 dot path. Point join where don't I need to take both of those? Point keys. Point key. Point and key. I could compute hashes of those to indicate that it's a unique point. Probably will do that. So int dot min value plus x it can be quite different. Oh. Let's try a bit different thing. Path. Where, what do we have? Join. Creates the elements of two sequences based on matching keys. Matching keys. Oh, wait. I could compute hash codes. Hash code would be if, yeah, I could compute hash codes. If I have x, no, it doesn't make sense, honestly. I cannot add them together. How do I get a hash code of a point? X and Y. Hash code of a point. Can't I join by equality compare? Outer key selector, inner key selector, result selector, comparer. And for this one, join by keys. I cannot have keys, so I cannot do a join. Hash code. So path. Oh, it's intersection. It's intersection, it's not join. Awesome. So I intersect wire 2, path. And I need to compare the two. Oh, don't go there. So I need to compare paths. Not paths, points. I need to compare points. So public. Wait. What's the default one for intersect? What do they do inside? Intersect. It takes first and second. Intersect iterator. Wow, weird. I equality comparer for a point. Okay, let's implement it then. Or let's see what's the result. Maybe it works as I expected to. It cannot know it for sure right now, so I will go to the point and equals to quick Google will help, I think. Link U intersect example. Default compare intersect objects. Okay, so I guess I'll write my own equality compare. It doesn't really compare. So let's do it. Point equality compare. Public class I equality compare for a point. Let's implement it. Quite trivial. Hash code. I have no idea. Hash code. No. No. Hash code. How do I compute hash code? Okay, I found this. I usually go with something like the implementation given in Josh Block's Fabulous Effective Java. It's fast and creates a pretty good hash, which is unlikely to cause collisions. Pick two different prime numbers and do this. Okay. I will just use the wisdom of Mr. John Skeet and steal his ideas. I have my full trust on him. Point dot x, point dot y. Wonderful. I should give credit to him, of course. And for equals is quite trivial. xy is, P1, P2, P1 x is P2x, and I return this. P1y equals P2y. Good. So let's go back. I definitely won't make in time today to finish this, but at the very least I will try to do the first part. Good night, Roelov, and he said, I'll study your solution tomorrow. This one makes me feel like AOC is too much for me. I wrote about my feelings in the Element of Code challenge. This was one for a line. This was my one for a line. Okay. So we intersect 2 points, and our equality provider is point compare. And var tangles is literally just that. We intersect with that. Yeah. Okay. Finds all the tangles between wire 1 and wire 2. So if I run this, it passes. Let's add a few more cases. So if I go right 1, left 1, and this one follows, then all of it will be a tangle. So 0, 1, 0, 1, 1, and left 1, left 1, right 1, this. Let's run. Expected item 1 to be, but found that. That is true. It's supposed to be 0. So I first go right, didn't go up yet. I didn't go up once, so y now is 1. Let's run again. Good. Now our tests pass, and now we have our tangles. So the tangles are done. The missing piece is finding the distance. And this one is extremely easy. Public point find closest tangle to origin. So we take in wire. No, we take in tangles. And we say return tangles order by, no, don't order by, min selector. Yeah, this is super easy. Return tangles where tangle t dot x plus ty x. What's wrong? Again, let's see the uploads. Selector, 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 selector. How does it know minimum value in generic sequence? How does it know which one is minimal? Let's see. Compare. How does compare work? Compares two objects, and it will compare them using the operator. So I will add the operator for comparison. Public static operator equals it takes a point, 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 2.1. And it's a bool in the end. Static bool. So we had the equality compare. Let's do it from there. Now I can actually just do super easy. P1 equals P2 is. And for this one, I say P1 dot X is P2 X return and P2 X and P1 Y is P2 Y. For this is good. Perfection. Let's test the point comparison if my operators work. Point tests. So let's say theory, fact, public void point, point X and Y matching in both points should result in points equality. And I say theory, and I say inline data, and I take in a bunch of stuff. So all zeros int x1, int x2. I'll actually take enumerable. Of object points comparison input. It's a get. Yield return new array that is point 0, 0, and another one 0, 0. And expected result true. Confusion much. Yield return new object. Yield return new object. What's wrong? Return value missing. I'm confused. If I look at this one, yeah, it's the same. Yield return new object. I don't need this. Oh my god. I do need this. Why can't you resolve yield? I had it in day 2 something. Public static. Right. And how come this one didn't need that? It does, okay. Wait. Yeah, wait. Object array and another array. Okay, if I do this, why is it not working? Okay, let's do exactly what we did here. Why are we creating a new... Oh, because that object itself was enumerable. I'm such a dumbass. Holy shit. Okay. New list of objects. Which this now goes in. KD. What is this? KD. So list of objects. So yield return new object. Why can't you resolve yield? Because I didn't yield. Okay, because it's not enumerable. Of course not. Okay. So what I wanted was comparison, test points comparison. So new point 0, 0 should match point 0, 0. True. I won't have true or false. Good. Paste, paste, paste. Then, I don't know, 10 doesn't make sense. 0 and 1, 1 and 0, and -1, or more like int max. Good. And that's point comparison equal points input equal points. And another thing that I want is unequal points. So let's mess either up. Zero. 0. Good. So for this one, I take 2 points. And I say P1 var are equal P1 P2. Are equal should be true. Member data, name of equal points, and it needs to be public static. and it needs to be public stat. Perfect. And let's make one more. Theory unequal points. X and Y mismatching in both points should result in points inequality. False. Comparing equal points should return true. Comparing unequal points should return false. Good. If I run my tests now, let's see if equality works. I am having some problems. Find tangles for wires. Crossed path 1. This is pretty easy. So wire 1 is new wire from path 1, and wire 2 is new wire from path 2. And I say find tangles. And probably I want another method which gets me the closest tangle. Yeah, probably I just want one method. So I say give me 2 wires, and I will give you tangles and then find the minimal. All right. Origin point is I need equality comparer as well. Okay, find point with coordinate sum smallest. Origin is the point where both wires started. This is not good. Oh no, this is good. Because they're two separate lines, so that's fine. Expectation for distance. Distance is 1. Yes. Distance is 1, as simple as that. Untangle wires. Returns closest intersection point. Returns closest intersection point. That's all I need. Wires. For tangles. Returns. Valid path distance, the path literals, returns all intersection points. Valid path literals return intersection points. Good. And we have two wires, we have cross sections. We don't want cross sections, we want find closest angle to origin, which is closest tangle, which is assert closest tangle should be distance, not tangle. Nah, I think this is two different things. I probably want this, and then again I want this. Find closest tangle. Calculate shortest distance to origin. So find closest tangle. And this is an int. Actually, this is a long because it can overflow if it's 2 ints max values. Tomorrow I'll finish with the tests and this part, but I just want to get the result in at this point. If I run my tests, okay. I want my tangles straight, so let's add one more to be sure. Let's actually use their input now, because it's the real deal. I think now it's useful to do the parse from file thing. So my wire can read stuff from a file. Public wire string path to panel file. File it's two different files, so I cannot read it from file. It will be a part of a demo, I think, reading it. Or maybe I create a panel, and a panel has wires. Yeah, I think that's good. So I create panel by passing wires, or by Right. The second option is by panel enumerable the path. Panel map. Right? How does it work? We say file dot read all lines and from config panel map. From panel map path var lines and then wires yeah, I say that wires is lines select new wire from a line. That's pretty much it. So I create a panel, and panel has public tangling thingy wire untangler, or maybe manager. So refactor extract interface of those things. Actually, I'll just hardcode dependency. Really feel bad though. Nah, I'll inject it. But it's core logic, so it's pointless. Honestly, it's pointless. Oh, but I might have versions of it, so I will inject it. Panel untangler sure, and public void find closest, I guess. And it makes sense for this one, probably. Maybe not. For the two wires, intersect second. I could keep intersecting actually. Anyways, for now, it's so easy to change though. Wires. In between wires. Wires, also wires, but this one will change. For each, no, more like, yeah, var tangles is new list, more like enumerable, point tangles. And now for each var tangle in wires, sorry, for each wire, I say tangles intersect with existing tangle. Only matching. I cannot do a for each. I need to start from the first one. Oh, but it can match with other ones. Oh, no, no, no. This is so much harder. Undo. So much harder. Untangler panel. So for panel, we will have a wire 1 and wire 2. Lines, right, which I split lines. So select line, which I then split by comma, and then I say select. So this is line, and this is So I have wires. Oh, my wires are actually, right. So wire 1, I evaluated to list. Wires 0, wire 2, wires 1. Should handle the exceptions, the edge cases, but it's late. Find closest means I call wire untangler dot calculate shortest. Okay. Good. So we go here. Expected distance works. Last tests are actual tests. So not very TDD, but whatever. Panel tests. So this will be literally just a file. Public panel tests. So public void panel panel initialized from file with 2 tangled wires it gives returns shortest tangle distance to origin. Distance is enough. So our input is inline data for half, and it's a theory because it takes input, and our directory is input slash first one string path to panel config, and we say var panel is new panel using panel config. And then we say panel var. We also get the expected result, which is 1. In expected distance var distance is panel dot calculate closest it takes 2 wires. Long. Oh shit. Good. And distance should be expected. Let's run. What's up with this? All right, we don't do this with the panel. Back, run. Failed. Could not find a part of the path because I didn't put always copy. Try again. I should build. Input tangled wires distance 1 txt. Okay, so what do we have? Input, right, day 3 slash. It's not part of supported literals. Root. Right, because that's not the map. Run again. Object reference. Oof, that's really bad. Okay, so where is it null? I don't pass untangler when I create a panel. Of course I don't, because come on. I should pass it. Sure, I pass it, but I don't do anything with it. Var untangler is untangler, and this bit will go to a function. Load wires, I'll call it. Let's run again. Come on, why did I put var? Okay, it's late. Stupid mistakes happening. Okay, it passes. Now let's add a few more cases based on the challenge. So this. Tangled wires dist, what was it, 159. One, 3, 5. Okay, and let's add more. One, 3, 5. 1, 5, 9. And run. Oh, wishful thinking, right? Couldn't find file because I didn't copy always. Build. Sequence contains no elements. Okay, I realized that I messed up. A tangle is not necessarily matching point, but it's a point that falls into the gap. So my solution is faulty. So I'll try to rework it tomorrow. So for now, see you guys and see you tomorrow. Thanks for watching.